Here we're asked to prove this trig identity, and I am going to go ahead and simplify the left side here specifically because it's kind of the more, and there's more to it. It's more stuff that I can simplify. It's a little bit easier to work with than if I was just working on the right side. So the first thing that I'm going to do, know that there are multiple ways to do this, some better than others. Personally, whenever I see like cosecant, then I usually like to switch that to sine. If I see secant, I like to switch it to cosine. So the way I'm going to do that to start is I'm just going to replace cosecant with 1 over sine of x, because that's one of our new trig functions that is very helpful. And cosecant becomes 1 over sine of x also. Now, at this point, I could do two things, and this is what I mean by like there's always multiple ways to do it. I could get a common denominator and simplify the top there, or step option 2, which is what I'm actually going to do, is I'm going to multiply by the reciprocal to get rid of this. Since this is already all together, I can really just multiply the top here by sine of x, sine of x over 1. And so I'm going to do that. This goes away, and then I distribute that here. So when I distribute that, what I end up getting is sine squared x minus, and that is 1. And so, again, sine x over sine x, and that simplifies. So I kind of did a couple steps in one there. So hopefully we understand how I got from purple to blue just by multiplying by the reciprocal and then simplifying that fraction there. So now the next step sometimes gets a little bit tricky. One thing that we should know is that we have this Pythagorean trig identity, sine squared plus cosine squared equals 1. Now, I see this sine squared, I see this 1, and so I'm going to look at this and try and figure out how I can use this identity to help me simplify this blue expression that I have. So over here in green, because I want sine squared minus 1, I'm going to subtract that from both sides. So I have sine squared minus 1 plus cosine squared x now equal to 0. I want this by itself, so I'm going to also subtract cosine squared, and I get sine squared of x minus 1 equals negative cosine squared x. So this right here tells me that I can replace sine squared minus 1 with negative cosine squared x. And that's good because that is what I wanted to match in the first place. So this one here is now proven because I have made the left side simplified down to match the right side.